Okay guys, so for 7.2, we're trying to create lines of best fit, and we pretty much pick up where we left off with 7.1, with just a little bit of additional vocabulary. So I copied it ahead of time just so that, again, we can save you guys a little bit of time on the video, but I'll talk about it briefly while you maybe pause the video and just copy down your vocab. So the line of best fit is what we're focused on today, as it's the title of the section, and it says that we need to create a straight line that goes through a set of data that best represents all of the relationship occurring with the lines. So you're basically trying to draw a line that gets as close to or touches as many of the points on your scatter plot as possible. And the way you do this in your with your method of drawing a best fit line, you have to pick 2 points to draw the line through that you think best represents all the rest of the points. And then you kind of just treat it how we did in the previous unit, where you would find the slope between those 2 points and then put it through the actual line itself, which we'll work on in the back. Then there's 2 types of ways you can answer questions based on your best fit line. You can use interpolation, which is an estimation of a value that is within the line, right? Interpolation, inter meaning within. Or you can use extrapolation, which is an estimation of a value that is outside your best fit line. So think of extra as meaning like outside. So interpolation, inter within, extrapolation, extra is outside. And then I did put on there that you can recall all 3 of your types of correlation. We have positive correlation.
Dustin Michaels to the nurse's office, please. Dustin Michaels to the nurse's office.
Sorry about that. We have negative correlation and we have no correlation, okay? And hopefully you remember from yesterday what that's all about. So I'm going to jump into just a few refresher problems to make sure that you remember kind of how to use relationships, and then we'll draw a best fit line. So it says, use the scatter plots to state the correlation and whether the coefficient of the correlation is closer to -1, 1, or 0. So this first correlation, you guys can see there's pretty much a downward trend, right? So I'm going to pretend that's like my best fit line. I'm just kind of taking a guess. But that is a negative correlation. The slope for the best fit line would obviously have to be negative then. And then my correlation coefficient would be close to -1 because I have negative correlation. This next one, let me actually try to do a better best fit line since we're going to practice that. I'm going to pretend that this point here and this point here are the 2 I'm going to choose for my best fit line. So I'm going to draw a line that goes right through both of those points, and that's actually not a best fit line, or not a bad best fit line, excuse me. That does a pretty good job. It gets pretty close to every dot on there, so I feel pretty good about that. And then for the type of correlation, it's obviously positive, which means the slope of my best fit line is sloping positive, which means my coefficient is going to be close to +1. Okay? But we're going to flip to the back and try to see if we can't actually create a best fit line here. Okay? So I kind of wrote over here the method or the steps that you could potentially use in order to draw a best fit line. Okay, right here. So some steps that are going to help you write the equation for your best fit line. Number 1, you need to draw the line through the 2 points that you feel like would appear to most accurately represent your scatter plot. Okay, and I'll try to give them to you this time just so you have a good idea. The second step is to find the slope between these 2 points. And you guys know that you can use this formula to do that, just like we practiced in Module 6. The next thing is to write the equation using the point-slope form, right? And we practiced that last unit as well. And then the last thing would be to convert your actual equation into slope-intercept form, which means it should look like this when it's all said and done. Okay, so you have a lot of these skills. It's just about trying to tap back into them and see if you can do the problems. So it says, write an equation for the best fit line of the given data. Step 1, draw your best fit line. Well, I actually just put it on there for you because I figured if I just put it on there for you, we would have a better chance to kind of get through these problems. Step 2, Find the slope between 2 points. Well, I gave you points to try to find the slope through. You'll typically have to pick them. I just gave them to you so that we would all kind of be consistent and use the same ones. So we have 4550, which 4550 is this coordinate right here. And then we have 6224, which is this coordinate right here. So those are the two that we're using. So let's find the slope. If you guys can recall, the slope should be found by taking the second y minus the first y and dividing out the second x minus the first x, which means I'm going to call this x1, this will be y1, this is x2, this is y2. So now I have this simplifying to 24 minus a 50 over 62 minus a 44. So if I grab my calculator here, it looks like 24 minus a 50 is going to get me a negative 26, and then 62 minus 44 is going to get me an 18. If I simplify by just dividing negative 26 divided by 18, that's going to get me like negative 1.44 is what my slope should be. Okay, so now we have a slope and we need to move on to the next step. Well, the next step is trying to ask me to identify the actual equation for the line. I'm going to have to use point slope form. Okay, so for point slope form, I need to scroll down just a bit. I need to take y minus the y1 coordinate equal to the slope that I just calculated of negative 1.44, and I need to put that into x minus the x1 coordinate. So just choose one of your 2 points. I'm going to use the 4450. Okay, so just as a reminder, 44 comma 50. I'm going to use that for x1 and that for y1, which means now my equation says y minus the y coordinate that I chose should equal my slope, and then x minus the x coordinate that I chose. So if you guys remember from last unit, then this slope needs to get distributed all the way through your equation. So now I have a y minus 50 equaling a negative 1.44, and then with an x on it because it got multiplied by the x. But then the next step makes me distribute that negative 1.44 all the way through to the negative 44. So on my calculator, negative 1.44 times a negative 44 should be getting me like a 63.36 positive, because they're both negative. 63.36. And then I'm going to add this 50 over so that I can get the y alone. So then I'll add 50 more in my calculator. So it looks like I have y equaling negative 1.44x all plus 113.36, like that. So if I feel good about this equation, then what I can do is say, well, that technically is step 4 because I put it into slope-intercept form, right? And now that I'm in slope-intercept form, I'm going to scroll down and try to answer some of these questions. And it might say, interpolation or extrapolation, we're going to have to determine whether the data they're asking us about is on our, like inside of our best fit line, or whether it's outside of our best fit line. So it says, about how many coats are sold per day when the temperature is 50 degrees. So go back up to your graph, find 50 degrees, take like an estimation. Okay, if this was 50 degrees, that would put my line somewhere here, right? This is definitely inside of our best fit line. So this is interpolation. Basically anything that occurs like anywhere on this line from here to here is going to be interpolation. Anything that occurs, like if they ask you to find something out here or something out here, that's going to be extrapolation because it's outside of our best fit line. So what I'll do is, since I know temperature is x, right? Temperature is x down here, and coats are y, I'm actually going to use my equation. And if it says about how many coats are sold per day when the temperature is 50, I know that in this equation, like we just said, your temperature right here is worth the x value, because that's where it was on my graph. It was on the x-axis. and my coats right here is worth the y value. So if it says about how many coats are sold per day when the temperature is 50 degrees, I know that for coats, I'm going to leave it as y because I'm trying to solve for it. But as the temperature, I'm going to do negative 1.44 times the x value, which is 50 degrees, then I'm going to add my 113.36. And I'll just solve. So I'll type in negative 1.44, multiply that times 50 degrees, add 113.36. And it looks like it should be approximately, 41 coats? Okay, and that is an example of interpolation because I found a set of data inside of my line. About how many coats are sold if the temp was 20 degrees. Go back and look at your graph. See now 20 degrees here, 20 degrees would be like in here somewhere. Which means if I looked up to 20 degrees, it's actually not on the line of the set of data I have. So this is an example of extrapolation. Okay, and I want to be clear about that. So this is an example of extrapolation. But I still set it up the same way. The temperature is still the y value, which means my 20 is y. And it says how many coats. So it wants to know, the temperature was the x value in the graph. The temperature is the x value. The y value is coats. So how many coats? Well, y equals negative 1.44x all plus 113.36. Right? Which means y equals negative 1.44x, but I know that x is 20 degrees in this problem, and I'll add the 113.36. Okay, so then I have a negative 1.44. I'm going to multiply that by 20. I will add that to 113.36. Which gets me approximately like 85 coats, right? So it should be about 85 coats. And that was extrapolation because I had to find a set of data that was outside my best fit line. Then it says, what temperature would it be if 20 coats were sold? Again, now this is backwards because they're saying 20 coats were sold, but 20 is our y value. So in this situation, I'm first going to go look at the graph and see if it's interpolation or extrapolation. So 20 coats were sold. Well, let's see. I'm actually going to clean this graph up a little bit as well. It's getting kind of messy. So let's see. When 20 coats were sold, that would be like here. So if I look across, that's definitely on my line, right? 20 coats is on my line. So that's interpolation, because it's inside the data. So 20 coats should equal negative 1.44x plus 113.36. So I need to solve for this x value right here, which means to get that x value alone, I've got some work to do. I have to subtract 113.36 from both sides. So 20 minus 113.36 gets me a negative 93.36. Now that's equal to a negative 1.44x. So I'm going to divide this negative 1.44x, and then I'm going to divide this negative 1.44. What's going to happen is these two here are going to cancel each other, and basically I'll be left with my x value. So in the calculator, just type in negative 93.36, but divide it by a negative 1.44. It looks like it's going to be about, what is that, 64.8 I got. So let's round it, about 65 65 degrees or so. Okay, so it's about 65 degrees or so. And then the last one, it says, what if the temperature outside, about what temperature would it be if there were 20 coats being sold? Oh, that's the same exact problem. I meant for this to be 0. Let's change that. Let's make that 0 coats. So let's go find out where 0 coats would be. So 0 coats is also not on your line, right? If you look here, if this were 0 coats and I looked across, right, it doesn't meet my data. Like there's an empty space here. So whenever you run into an empty space, you can still predict, because you can pretend that your line would just keep on going, right, and see what happens. But that's why it's called extrapolation, is because your line's not actually there. So for this one, definitely say extrapolation. But then when you do the problem, and I'm sorry, I meant to type in 0 for that one. If there were 0 coats sold, that means that your y value would have been 0. So 0 coats equals negative 1.44x, all plus 113.36. So to solve for this, subtract out this 113.36 from both sides. Now what happens is a negative 113.36 will be equal to a negative 1.44x. Do the same thing we did last time. Divide out your negative 1.44 on both sides. So divide the negative 1.4, well, I'm at the bottom of the screen. Let's just bring this up a little bit higher. So negative 113.36 was equal to a negative 1.44x. Now, divide your negative 1.44 on this side, divide your negative 1.44 on this side, and your x value will be left by itself, seeing as x equals essentially whatever comes out of this side of the equation. So negative 113.36 should be divided by a negative 1.44. And it looks like it would be about, I'm going to squiggle these because it's not exact because we're rounding here, it would be about 79 degrees, right? Because I got 78.72222, which would be about 79 degrees. Okay? So good luck. Let me know if you guys have any questions along the way.